Okay, guys, with real medical data imagery that you can get from Kaggle, you can get the skin cancer data set. You get a train folder and a test folder. Okay, we're going to build a cancer prediction model. Okay, because there are medical uses in AI, which you're going to see right now. Many doctors make mistakes with skin cancer imagery a lot. They misdiagnose it for something else. Okay. Okay, so train set equals file one, which was the training folder. And then horizontal flip, this is some basic data augmentation. Another thing we do down there is max pulling for data augmentation as well. But okay, and then the test set. The reason why I did 16 instead of 32 was there was less pictures. Okay, and then binary class mode, because this is a binary data set. 384 is the thing I chose for the target size, which is the input shape. Dense 1, because it's a binary, remember? And then it has to be at the end or end. It has to begin or end in 1 as well, because it's binary. If it were cross-categorical, you would add how many neurons are in that category, in the classes, I mean. Okay, I did the same I did for the Python, just because the Python or Anaconda, just because it worked. I had a feeling it would, without needing to change any of these pool size or kernel size, or do a different shape with the convolutions. This is the shape I like to keep with a lot of the pictures. Then I only need to add dropouts whenever it stops learning. Okay. Cn equals, the reason why it only says 5 epochs is I added 5 more epochs. I originally ran it at 30, but I felt like it needed 5 more, but it really didn't matter because the model performed good. Okay, here's benign. Remember the 2 ways I showed you how to predict? This is the simple way, which is not always the best, and I'm going to show you why. Yes, benign, but malignant, it is not. But I'm going to show you here, malignant, right? The same picture. 18% chance benign, 82% malignant. Now, why did it get a totally different prediction? I'll tell you why. Because you're using CV2 with the image size equals 384 from the input shape. And then image array, IM color, and then you reshape the array, def, predict, prepare, and then boom. Okay. Now let's go to the benign one. 100% confidence, which is good. These were real imagery as well. And then these were new pictures I tested it on. So as you can see, by the way, this is how CV2 looks before you put it on the grayscale most of the time in imagery. Okay, guys. Now you see why you shouldn't do it this way. You should prepare the image this way. This is why. And let me show you something. With the Keras load model function, you can always load the model you saved as an H5 file. I got it somewhere around here. Hold on. Hold on. Here. You can always download this. Then when you download it, you can even send it in an email if it's not too big, and then you could send it to yourself. use the Keras.load model function. You know the input shape it was loaded in, and then you do that formula right down there. As long as you trained it in 384, you should be good. Because remember I showed you guys? Image size 384, which is the same as your target shape and your input shape. Because it's on the same axis. Now, you might have to switch this to 1 depending on your axis, but most of the time, no. Okay, guys, that's it. Thank you. By the way, get this data set from Kaggle. AI is used in medicine a lot. Thank you.